Objective 5, Miscellaneous Equations, Part 2. We're going to go through uh, three equations, fairly routine in nature, but nonetheless you'll see things like this in calculus, so it's worth going through. First of all, 2 times x minus 5 squared x minus 6 cubed minus 4 times x minus 5 cubed x minus 6 squared equals 0. Interesting equation. X equals 5 is a solution, obviously, because it makes that 0, makes that 0. X equals 6 is a solution to the equation. Makes both factors 0, both terms 0. There is another 0, and we'll see if we can find it. And we can factor. If you look at 2 and 4, we can factor out 2. We have two factors of x minus 5 and 3, so we're going to factor x minus 5 squared. Third power, second power, x minus 6 squared. And then we have to ask, if this is factored out of here, well, we took the 2 out, we took both of those, we took all but one of those, so we have an x minus 6. Now if we take that out of here, take 2 out of 4, that leaves minus 2. We took both of those, but we have one of the x minus 5s left. And so there we have it. Now this could be broken down, of course. We have 2 times x minus 5 squared, x minus 6 squared, x minus 6 minus 2x plus 10 equals 0. 2x minus 5 squared, negative x plus 4 equals 0. Now here's the zeros. We have x equals 5, multiplicity 2, x equals 6, multiplicity 2, and this one is x equals 4. Negative 4 plus 4 is 0. And that's all the zeros. Number 2, seemingly complicated equation, is actually quite simple. All we care about is making the numerator 0, because if the numerator is 0, 0 divided by anything is 0. As long as the denominator, we're not 0 as well. So 2x equals 1, x equals 1/2. Very simple principle. There are a lot of these fractional equations in calculus. You just grab the numerator and solve that. Now we have two fractions. First one has denominator x minus 1, x minus 2, and the second one x minus 2, x plus 1. We need an LCD, x minus 1, x minus 2, x plus 1. That includes all the factors. And then what we're going to do is multiply this fraction by x plus 1 over x plus 1, multiply this by x minus 1 over x minus 1. So we have, let me back up here a second, x minus 1, x minus 2, x plus 1. We're missing an x plus 1. And then we have minus 2 over x minus 2, x plus 1, times x minus 1 over x minus 1 equals 0. This one takes up a little more space. And so now we can multiply x times this, and we have x squared plus x over, how about if I just write LCD? 2 times x minus 1. And then we could subtract. It gives us x squared plus x minus 2x plus 2 over LCD equals 0. Combine like terms, x squared minus x plus 2. And then like we said before, we really only care about the numerator. as long as we don't have 0 divided by 0. So if we were to solve, set the numerator equal to 0, and we were to come up with 1, 2, or negative 1, it would not be a solution. It's what's called an extraneous solution, because you can't have 0 divided by 0 equaling 0. So we're going to set x squared minus x plus 2 equals 0, and apply the quadratic formula. That doesn't factor. We get x equals negative b plus or minus square root b squared minus 4 times a times c over 2 times a. Okay, and we have 1 plus or minus 1 minus 8 is square root negative 7 over 2. And we get 1 plus or minus I radical 7 over 2. Okay, there are two solutions to that equation. And none of them give us are extraneous. Obviously, we don't see 1, minus 1, or 2 on that list. So, okay, that concludes the miscellaneous equations. These are things you just see in calculus that are good to know. We'll be back with Objective 6 shortly.